2025 is really shaping up to be a huge moment for AI. We're talking about a leap beyond the simple prompt and response models we've gotten used to. We're moving to something way more powerful, truly autonomous AI agents that can actually reason, plan, and execute complex tasks all on their own. So today, we're going to dive deep into how these agents work, and we'll compare two of the most powerful frameworks out there for building them, LangChain and AutoGen.
Okay, so let's just jump right in with a pretty provocative question. Are your current AI systems just glorified chatbots? I know, it's a tough question to ask, but the tech is moving so incredibly fast that what was cutting edge yesterday is, well, just the baseline today. We're really talking about a fundamental shift from reactive tools to proactive, autonomous systems that actually get things done.
So what's the real difference here? Well, on one side, you've got traditional automation. Think of it as being super rigid, right? It's all rule-based, following a static, if this, then that kind of workflow. But on the other side, you have agentic systems. And these are a whole different ballgame. They're goal-driven, they're adaptive. The key, the absolute game changer, is their ability to reason and make decisions on the fly, not just blindly follow a pre-written script. To really get our heads around this leap, we need to look under the hood at the anatomy of an agent. So, what are the core components that give it this incredible power of autonomous action? It really breaks down into four key parts that all work together in this continuous, elegant loop. It all kicks off with perception. This is the agent's power to sense its environment. It's taking in all this data, from user queries, system metrics, maybe even real-world sensors, and processing it into a format it can actually understand. You can really think of this as the agent's eyes and ears.
And next up is reasoning. Now, at the heart of every modern agent is a large language model, an LLM, which basically acts as its brain. The LLM gets that perceived information and uses its massive knowledge base to make decisions, come up with a plan, and break down these big, complex goals into smaller, totally manageable subtasks. This is literally where the thinking happens.
Okay, so once a plan is in place, the agent has to actually do something, right? The action component is like the agent's hands. It lets it interact with the digital world by calling external tools, connecting to APIs, and carrying out the steps that were laid out in its plan. This is how the agent actually gets stuff done. And finally, we have something that's absolutely critical: memory. Without memory, an agent is just reacting to whatever's happening in the present moment. Memory is what gives it continuity. It allows it to learn from past interactions, maintain context across a really long series of steps, and make decisions that are consistent and relevant over time. And here's how it all comes together in what we call the agentic loop. It's beautiful, really. The agent perceives its environment through observation, it thinks about what to do next through reasoning, and then it takes an action. The outcome of that action, well, that becomes a brand new observation, and this cycle just repeats over and over continuously until the goal is finally achieved.
Now let's be real, you can't build these incredibly sophisticated agents from scratch every single time. That would be insane. That's where frameworks come in. They give us the essential software foundation, the toolkit, if you will, that lets developers build production-ready, scalable agents. So let's take a look at two of the heavyweights in the space.
First up, we've got LangChain, which is one of the most established players in the game. Its main strength is this massive ecosystem of pre-built components that lets you build specialized agents super fast. But its extension, LangGraph, is where things get really interesting. It lets you define these complex, stateful agent behaviors as a visual graph, which is just perfect for workflows that have sophisticated, cyclical logic.
Yeah, think of it like a flowchart for your AI. With LangGraph, every node in the graph can be an agent or a specific tool, like a web search, for example. The edges then define how information and state pass between them. This gives you this explicit, deterministic control over really complex behavior, making it perfect for those high-stakes workflows where every single step has to be auditable. Then, on the other side of the ring, we have Microsoft's AutoGen. And AutoGen's philosophy is totally different. It's built around this idea of a multi-agent conversation. So instead of a rigid graph, you create a team of specialized agents that collaborate by talking to each other to solve a problem. It's a much more flexible, event-driven approach, which means agents react to messages from each other instead of just following a predefined path. It is all about orchestration.
So there you have it, two incredibly powerful frameworks with two very different philosophies. The big question is which one is right for your project? Let's break down the comparison and see how they really stack up head to head. All right, let's really get into the nitty-gritty here, because the choice you make is crucial. First, let's talk architecture. LangGraph is graph-based and stateful. It's that predictable flowchart we were talking about. AutoGen, on the other hand, is chat-based and event-driven, which is much more like a dynamic team meeting. This leads directly to what they're best for. LangGraph's deterministic control makes it the go-to for structured, predictable enterprise workflows. AutoGen, though, really shines when you need a collaborative team of agents to tackle more ambiguous problems, like complex research or creative coding tasks. Next up, orchestration style. LangGraph gives you that fine-grained control with an explicit state machine that you define. AutoGen uses a more fluid, turn-based conversation between its agents. And finally, observability. Both offer really strong tools. LangGraph integrates super tightly with LangSmith for crystal-clear state tracking, while AutoGen has its own powerful solutions like AutoGen Studio for visualizing those agent conversations. Look, this isn't just theory, right? This stuff is happening now. So let's see how this all translates into tangible business impact across different industries.
Take supply chain management, for instance. A global electronics manufacturer used an AI agent to monitor hundreds of suppliers. Now, when a disruption happened, the agent didn't just send an alert. No way! It autonomously identified alternatives, drafted and sent out inquiries for new contracts, and rerouted shipments, often solving the problem before a human manager even knew it existed. The result? A 30% reduction in inventory carrying costs. Pretty incredible.
And the impact in the legal world is just as dramatic. One firm deployed AI agents to handle the incredibly tedious work of document analysis and case screening. By automating this process, they were able to reduce review time by a staggering 90%. That freed up their highly paid legal experts to focus on what they do best: strategy and client work.
And the applications are just so broad. I mean, in IT operations, agents are creating self-healing infrastructure. In finance, they're spotting complex fraud in real time. In software development, they're acting as autonomous coding assistants, writing and debugging code. And in manufacturing, they're enabling predictive maintenance before a failure ever even occurs.
So the potential is clearly enormous, but building reliable and effective agents, well, that requires a really thoughtful approach. So it's crucial to understand both the best practices for implementation and the pretty significant challenges that are still ahead of us.
And, it often starts right here. You can have the most sophisticated architecture in the world, but if your system prompt is just an afterthought, your agent is going to be erratic. A clear, explicit prompt is the absolute foundation for predictable behavior. It's not just an instruction, it's the agent's constitution.
So how do you build them right? Well, here are 4 key best practices. First, start simple. Seriously, don't over-engineer from day one. Just pick a scalable architecture. Second, establish your metrics early on so you can measure things like accuracy, cost, and latency. Third, as we just saw, you have to invest heavily in prompt engineering. And fourth, always remember, an agent is only as good as the information it receives, so you have to ensure high-quality data.
Of course, it's not all smooth sailing. With this incredible new level of autonomy come new challenges that we absolutely have to solve. First is reliability at scale. An agent that works perfectly in a demo needs to be rock solid in production. Next is security. How do you stop autonomous agents from being manipulated or causing harm? Then there's complexity and cost. Managing these multi-agent systems and all their LLM calls can get complicated and expensive fast. These are the big engineering hurdles we're all tackling right now.
But despite those challenges, the agentic future is arriving fast. So I'll leave you with this final thought. Your first AI employee, an autonomous agent that's capable of handling complex digital work, is ready to be hired. So what will you have it do? The answer to that question is going to define the next wave of innovation.